In this lesson, we're going to review the cosine law. Nice thing is there's no new parts pieces to add. Unlike the sine law, there's no ambiguous case. But we are going to be using the cosine law down the road to solve some trig problems, so we need to review it. The idea of the cosine law is the situations we cannot use the sine law in. That is, we don't know a pair of side and angles that go together. There are two situations we could have. We could have a non-right triangle where we know all three sides, so obviously no pairs. Or we could have two sides and the contained angle. That means the angle between two known sides. Again, you don't have a pair because you don't know the side across from it, and you don't know either of the other two angles. And so it's the only two situations we can use the cosine law for. So like the sine law, there's only really two problems we can do with this trigonometry. Okay, so here's the cosine law. Reminders, capital letters are angles still, small letters are corresponding opposite sides. The key with the cosine law is the letter A's. The A's are the things you want to find. You're going to know one and have to find the other. They're the things that are across from each other in the formula. B and C are interchangeable. It doesn't matter which is B and which is C. All that matters is the A's. Across from each other, and you know one of the two. And so look at problem number one, the nice one. I want to find my unknown measure. If this is letter X and it's a side, it's got to be a small a. Corresponding opposite angle, big A. B and C, interchangeable. So when I set this up, I get A squared equals B squared plus C squared minus 2 times B times C times the cos of the contained angle, which is 30. And we can put all that stuff into our calculator at one time because X is already by itself. Kind of what we want. If we do that, we end up with 263.36. Remember, that's X squared. So to get X, we need to square root. And if you do square root, you should get 16.23 meters. Okay. The two intermediate lines, these two, I don't really need to see that. First line, sure, put the right numbers in the right spots. You should be able to do it all in your calculator and square root it. So all you need is the final one. If we try the second one, obviously this is the second problem, we're missing the angle this time. So big A for the angle, little a for the side. B and C are interchangeable. If I tried setting this up in the same way I had it previously, I'd end up with A squared equals B squared plus C squared minus 2 times B times C times the cos of my angle. Well, my letter is not by itself. So I'd have to rearrange this equation to get cos x by itself. Now I can do that the way this is. Okay, there's nothing wrong with rearranging all the numbers, but it's actually easier to rearrange the equation first. So you might recall from last year, we had a second version of the cosine law where things have been rearranged. Here's our rearrangement. And just in case you're curious where it came from, a squared equals b squared plus c squared minus 2bc cos a. What we've done is we've taken this piece and brought it over to the left side, and the a and brought it over to the right side. Okay, so if we do that, you end up with 2bc cos a equals b squared plus c squared minus a squared. And then we divide all that, we get rid of the 2bc, so we divide by 2bc, and there's our formula. Okay, so just quickly where it came from. So I'm not going to use the red version. I'm going to change it and rearrange my equation the way I want it. So my cos of my angle equals b squared plus c squared minus a squared. Now be careful, this is the one place people mess up. They forget that a has to be at the end. Over 2bc. Now because I want to find an angle, we're going to have to take an inverse. To do an inverse, I like the fraction form better. So I'm going to figure out the top of the fraction, the 72 squared a squared minus 65 squared, that's 7359. And the bottom of it, 11,520. And then I take my inverse of all that big mass, and I can let my calculator do the work for me, just divide by, and use my brackets. And I get an answer of 50.3 degrees. I don't expect you to memorize formulas. I will give you both versions of cosine all the time. I just need you to know how to use it and when to use it. Okay, we'll try a couple applications. So we have a drive belt that wraps around 3 pulleys as shown. Find the length of the belt. Well, I know one part of the belt. I know the second part of the belt. All I need is the third part. This is the perfect cosine law, where A and A are across from each other. So I can use B as 14.5, C as 16, and plug everything into the right spots. My angle is 35. I'm going to plug it all in. I'm going to square root it, so I get x, and I get x is 9.28. The question wasn't how big is x, it was how big the belt is. So our belt actually made up of the three pieces, so the 14.5, the 16, and the 9.28, which gives us a total of 39.78 centimeters. Okay, let's try the next one. The pendulum of a grandfather clock is 100 centimeters long. When it swings from one side to the other, the horizontal distance it travels is 9.6 centimeters. Let's figure out the angle through which the pendulum swings. So we've got a pendulum, but it's going to swing this way and then swing this way. So we're going to end up with a triangle. The pendulum's 100 centimeters, or 1 meter. The horizontal distance it swings, so the triangle piece, is 9.6 centimeters, and we want to know the angle. So there's our big A, there's our little a. This is an angle one, so I'm going to use my cos of x. B and C are interchangeable, especially this time because they're both 100. Make sure we subtract the A goes at the end, over to B, C. Okay, I want to figure out the fraction. So on the top, I put it on my calculator, I get 19,907.84. On the bottom, 20,000. I'm going to take the inverse cos of that stuff. Oops, 20,000, not 10,000. And I get an answer of approximately 5.5 degrees. Not a big swing. Okay, last one. A sailboat traveled 9.2 kilometers on a bearing of 147. So we're talking about bearings here. You might remember from bearings in grade 10 that we have two ways of measuring bearings: north, east, south, and west. Cardinal directions. So if we came across something like north 30 east, we know we start north and go 30 towards the east. That would give me a bearing. Or we can also talk about bearings in terms of zero. Okay, when we work with the zero version, we go clockwise around. So if we came across a bearing of, like this case, 147 degrees, we know it's somewhere between 90 and 180. And because this is 90, 147 would be 57 degrees past, right? The whole thing has to be 147. Okay, so just some reminders about bearings. So we're going to draw a compass, which is the whole question now, okay? Here's my compass. 147 we said is down here. The whole thing is 147, which makes this bit 57 degrees. We are going 9.2 kilometers that direction. We then traveled 5.1 kilometers and bearing of 265. Every time we change our bearing, we need a new compass. So 265 again starts at 0 and has to go all the way around, not quite 270, just below 270. 265. How much below 170? Or sorry, 270? 5 degrees, right? Okay. Our boat goes 5.1 kilometers. We want to know how far is the boat from the starting point. So that would be our x. Now it kind of looks like a cosine law question. We have two sides and part of the angle in between, which means we should be able to use the cosine law. One trick you may remember about compasses. Compasses are always parallel. Because they're parallel, we can always make the letter Z. Okay, which means if this is 57 up here, this is also 57 in here, giving us a complete contained angle of 62 degrees. So if we want to get x, and the A has to obviously be the big angle, and the little a will be the small angle. So we'll get 9.2 squared plus 5.1 squared minus 2 times 9.2 times 5.1 times the cos of our contained angle, which we said was 62 degrees. All into our calculator, then square root it. we'll get 8.16 kilometers. And that's the end. Okay, reminding us some things about the cosine law, how we can use it, solve some simple problems.